them principal axes. Okay? This is the question. Yes, Joseph?
For the inertia matrix, are there any properties that are preserved through this transformation? Like
the inertia matrix itself, it's a symmetric matrix, right? Also, like
is there some idea of magnitude that remains constant throughout this transformation, or
no?
Okay.
Yeah, this is why we're posing this question, which is, well, if I have some eyes and I want to get the axes that has the maximum and minimum inertia, how can I get that? So here is simply the case. So the principal axes, axes of maximum and minimum inertia. And actually, they also correspond to no products of inertia. So I will be simply I11, I22, I33, and zero products of inertia, where one of these two I's will be the maximum I ever, and one of these three I's, so it's not two I's. One of these three I's will be the maximum I ever, and one of them will be the minimum I ever, that you can see, and one is intermediate. So whenever you have a rigid body, there is an axis of maximum inertia, an axis of minimum inertia, and an axis of intermediate inertia. Okay? And we want to know what is this axis of maximum inertia and axis of minimum inertia. It might not be obvious. If the body is symmetric, that's fine. If the body is not symmetric, then it's not a trivial problem then. Okay? Any question? Let's see how to get that. How to rotate I. I have a generic I matrix that has 9 elements. It's a symmetric. Okay? It has 9 elements, no zeros. And I want to do a transformation R that delivers me here. But I don't know what's this R a priori. How much angle should I rotate? Okay? This is the question. Well, okay, I know how I transforms in this equation, or the blue equation. Let's start with the blue equation. I in the body times R equals R times I only, inertia. This is the full, and this is the one that I like, which is simply I11, I22, I33, right? This is its structure. I know it a priori. Okay? So I will just remove the E here. Simply, I'm starting with some inertia matrix given full 9 by 9, and I want to arrive at here. Okay? Any questions so far, please? Please, if you have any questions, just stop me. Yeah. I know that I'm fast, so we want to cover a lot of stuff. But the only way to stop me is to simply stop me. So please, if you have any question, just feel free to ask. Okay, let's do the multiplication. Let's get the first row here. The first row of this multiplication. What's that? I11, 0, 0 times the first column. So it gives you I11 times R11. This is the first element, right? Let's multiply the first row again times the second. You get I11 again times the second element, which is R12. And also R13. This is the first row. Anybody doesn't see that this is the first row? Okay? Okay, equals the first row from there. So R by the first row, which is the first row of R, R11, 12, 13, times I, actually. If you want to get the first row of the multiplication, it's the first row of this matrix multiplied the whole matrix. Okay? Now I'm going to do transpose because we typically don't like to work in terms of rows. Let's write in terms of columns. Let's do transpose for this equation. So I have, this is a scalar I11, it will just come down as is, and this row will be a column. R11, R12, R13. I'll give you some time to write, just bear with me please. I have two things here, I'm going to do the transpose, so you get I transpose first, right? When you do the transpose, you have the swap. And the transpose of this guy is just a column R11, R12, R13, correct? Can you tell me what is I transpose, please?
Same.
It's the same because I is symmetric. Okay? Any questions so far? Any question? Any question? Because you should tell me what is this red statement. What's that? A matrix times a column equals some number times the same column. What's that? It's an eigenvalue problem. So this means, this is very interesting, I'm given some I which is full of numbers, and I'm looking for the maximum and minimum inertia. They are simply equal the eigenvalues of R, right? So I11 is one of the eigenvalues of your I matrix, and the corresponding eigenvector, this guy, what's this? This is the first row of your rotation matrix. Because remember, what I'm given here, what is the problem? What is the problem here? The problem is simply I'm given some rotation matrix, right? Some inertia matrix. I'm given some inertia. What are you looking for? I'm looking for the maximum, minimum inertia, which are equivalent to, please give me the three principal inertias. One of them will be the maximum, one of them will be the minimum, and one intermediate. Not only that, I'm looking also for the rotation matrix that will rotate me from this inertia to the inertia corresponding to the principal axis, right? So I'm looking for the principal inertias and the rotation simultaneously. And here you are. What are the principal inertias? I11, 2, 2, 3, 3. Simply they are the eigenvalues of R. This means that I11 is the eigenvalue of R, right? And what is the corresponding eigenvector? This is the corresponding eigenvector. What does this represent? Actually, it was the first row in your rotation matrix that you're looking for. Okay? So, in summary, where should I write my summary? Maybe we can write it above here. And I'll just pull it up so that you have both pictures. So given some I, please get its eigenvalues, right? Lambda 1, lambda 2, lambda 3, these are the three eigenvalues. And the corresponding eigenvectors, V1, V2, V3, these are the results of the MATLAB command I of I, right? Then your inertia matrix, the principal inertia, which is I11, I22, I33. These are actually simply the lambda 1, lambda 2, lambda 3 over the diagonal. And more importantly, your rotation matrix that will deliver you from the old inertia to the new principal inertia, simply having these vectors as rows. So this is V1 transpose, to write it as a row, V2 transpose, V3 transpose. This is your rotation matrix. Okay? Which means, if you take this rotation matrix and substitute it here, R times your old I times your R transpose, what you will get?
That.
Yes, you will get a diagonal matrix having these three values over there, right? Any question? Now I'll just move this up so that you have both pictures.
So which one out of them is the principal, major, minor, and the
Yeah,
intermediate?
it depends on the values.
From the values
They are
maybe?
not always ordered. You just look at the three values. The maximum,
maximum
one
is
the
the
maximum, the minimum is the minimum. Yes, Michael?
The red statement in the second blackboard, I just, well, I understand what did you do. It's the first row in the blackboard. What did you do to get it?
I did transpose, simply transpose. Do you know transpose?
Yeah, but there's a transpose that you have. Just,
Yes, so we said
What have you done?
I transpose simply equals I, because I is a symmetric matrix. So it's equal its own transpose. You have your 5 now to write, if you like. I'll take some example, not on the rigid body kinematics. I think they are straightforward, but the dynamics are always tricky. So we're going to take, we already had one example before. And take another example now on rigid body dynamics. Homework 2 will be posted immediately after this lecture and will be due next week. It's on rigid body kinematics and dynamics.